Some of the tumors that are cured by microRNAs, we work on ovarian cancer because it's the 5th leading cause of cancer death in women. It is the most common gynecological malignancy. And we are working on the most devastating of it's called papillary serous ovarian cancer. And what we have found, so very interestingly, the very first tumor suppressor microRNA we discovered together with Dr. Matsuk and Dr. Anderson and us, the team with Baylor, the very exciting discovery was a potent killer of the specific cancer cell lines that come from this type of tumor. These cell lines are essentially, tumor cells that have been taken and then grown in a flask, right? That allows us to do research. But one thing we were struck by is not all of these cells were sensitive to this microRNA, which seemed to me awfully like the chemotherapy drugs. Because if you take the problem of cancer today, one could almost say that cancer is at some level curable because some people respond and now go on to live. But some people die, and why? And we were finding the same thing with our tumor suppressor microRNAs. But now, since we have the whole genome in front of us, we can go and look back at the genomes and see what's the difference. And what we were finding is that for this first microRNA that was discovered by Dr. Matsuk, Anderson, and myself, and also Dr. Chad Creighton at the Dan Duncan Cancer Center. He's a biostatistician who puts all this together for us. Looks like it is specifically targets and kills cells that are missing the RNA of this one gene called P53. And P53, if you take all of the cancers that are known today, about half of the cancers have lost the function of P53. And if you take the ovarian cancer that we were studying, 90% of the people have lost P53. So which is really exciting microRNA that can target and kill P53 deficient cells, but the 10% that have intact P53 does not respond, which to me is hugely exciting, because what that says is our genomes are our genomes are exquisitely sensitive to agents and sensitive based on our genotype. So in other words, we are going to move in the future to finding drugs, whether it's microRNAs or more sophisticated drugs, that are matched to genomes. And so when a patient walks through the door, one day I'm hoping that we will have a barcode, which is our genome, and that we will be swiped, and all the information will be out there, and we will be able to hand-pick the microRNAs or the drugs that will specifically target and kill, the types of tumors we are carrying. And so the second discovery from our group is the idea of individualized therapies. That the ultimate goal of our group, both the ovarian cancer group, and I also work on neuroblastoma, a devastating cancer in children, and where a lot of children die of. It's the same. We have some very exciting microRNAs that by themselves, a 22-letter RNA, can kill and shrink an entire tumor. This is work of Dr. Jason Shohet at Texas Children's Hospital in collaboration with us. But once again, we find that some kids will respond and some will not. And so the power of genomics is to not only deliver these agents to us through discovery, but also reveal the genomes that we are treating. And so we will be moving in the future to this exciting era of what I call RNA therapy, where you don't need to make a fancy drug. You know exactly, all you need is a 22 nucleotide RNA, and that doesn't need to be designed, right? That can go and pull down an entire disease network. But not only that, we will be able to match which RNA can attack which genome.